Welcome to Section 7, Reliability, Backup, and Disaster Recovery Principles. We are going to cover a few topics regarding reliability and disaster recovery, like cross-availability zone across region design principles, S3 cross-region replication, life cycles in S3, versioning and glacier integration, elastic block store and RDS backup and disaster recovery methods, and also trick about how to trigger backup in AWS using Lambda and CloudWatch events. Let's start with cross-availability zone and cross-region design principles. We are going to talk about reliability, we are going to talk about high availability and implementation, and key services to take into account for disaster recovery design of our architecture. Why? Because everything fails all the time. So I like this quote from Werner Vogels, this Amazon's CTO. He said that in the last 2017 reInvent, and I agree. So we have to design and to implement our services thinking that everything fails all the time. So let's start talking about reliability. Reliability is a pillar of the well-architected framework, as you can see here in the link in the screen. So reliability is the ability of a system to recover from infrastructure or service disruptions. So dynamically acquire computing resources to meet demand and mitigate also disruptions such as misconfigurations or network issues, etc. So let's see some design principles important to a proper reliability design. So first of all, test recovery procedures. So you can use automation to simulate different failures or to recreate scenarios, take down instances or services, etc. So if you fail fast, you fix fast and you improve your infrastructure. Automatically recover from failure. You have to be able to trigger automation when threshold is breached or when issue has been detected. So you can automatically send notification and tracking failures, and also to trigger an automation recovery process or a workaround to repair the failure. Scale horizontally. You have to be ready and you have to design your infrastructure to grow using autoscaling groups, for example. So following the demand of your service, you can add or remove more resources. Stop guessing capacity. So automate the addition or removal of resources to maintain the optimal level to satisfy the demand without over provisioning or under provisioning. So that's one of the keys of the cloud, right? So elasticity. And perform your changes with automation. So remember that we have some automation tools in AWS or third parties to perform all the changes following automation. Don't do changes manually in your servers or the operating system or even in the infrastructure. Use configuration management and infrastructure as code principles. And also in terms of availability, so we have here a table, interesting table that we are going to discuss in the next slide about the percentage and the max disruptions per year and how we can or to what we can apply this availability percentage. For example, 99% is going to be around 3 days and 15 hours per year of disruption. So this is, of course, for information that is not very critical, like things like batch processing, data extraction, transfer, jobs, etc. 99.9 are 8 hours and 45 minutes for other kind of tasks or applications, up to 5 minutes a year, which is 5 nines, which is something more important like ATM transactions, telecommunication systems, etc. So let's see an implementation example for high availability to understand a little bit better what are the services and why it makes sense or not to do A or B kind of design. So for example, we run a web application, we use a reverse proxy to getting static content from S3, an application server, an SQL database for persistent storage of data, and we can also deploy it using containers or virtual machine. Doesn't matter for this example. So we use EC2 instances. We use RDS for database, we use Route 53 for DNS, ELB as a load balancer, of course, and S3 for the static content. First scenario. So using a single region So we are going to have 99% of availability if we use a single region and a single availability zone. So we deploy the application and the database in a single instance. Everything is in the single instance. So despite EC2 has redundancy in the infrastructure underneath the service and the virtual machines, the instances, we are having a single point of failure. So we can create an encrypted backup in S3, and also the recovery time will make, of course, the availability of our service in case of incident. So the time that we take to recover is going to depend of our procedures, etc. But we have to rely our availability in our backup, not in the infrastructure design. We are having just single point of failure, like a single availability zone, a single region, and everything is in a single instance, etc. 99.9. This is also in a single region, but using two availability zones. So we can separate also tier with ELB, the EC2 instance using autoscaling groups to scale horizontally when needed. And remember also that autoscaling groups can give us the ability to create a new instance if one instance is gone or has been shut down or doesn't work for whatever reason. Also, we use another tier of RDS in multi-AZ mode, which is even more redundant. So we are using two availability zones, our service across two availability zones, ELB, which is per se high available service, EC2 in autoscaling groups, another high available service using EC2 using autoscaling groups, RDS multi-AZ, and the database backup and restore can be done with RDS. So we are increasing more our service and the availability. So for example, another service is the 99.99%. So using three availability zones in the same region, and additionally we add CloudFront to provide geographically caching. So in this case, the 99% for applications that are helpful for the business, for example, but is only inconvenient if the applications are unavailable. 99.9 applications for which it's important for them to have a high available, but they can tolerate short periods of unavailability. And the 4 nines are for mission critical applications that are main or significant for the revenue of the company. For example, a business to business web service or a high traffic content media site. So we have a multi-region scenarios as well. So we can use Route 53 as a key service to balance the network connection between regions. And in that case, we can use our 99.95% with recovery time between 1 and 30 minutes. So we can use something like hot standby approach. So having everything replicated in another region. And once we detect one issue in region A, we can move everything to region B using Route 53. And the higher, like 5 nines, in that approach, we should use something, it depends on the application, of course, this is not written in stone, but we should use something like NoSQL database, for example, because it's better for this kind of requirements, using active or multi-master approach, using, of course, Route 53 as routing, and 10 seconds intervals for health checks, for example. So we can see here an example of a service. We have the tenants and share onboarding in a specific region, and then we place the tenants depending on how close are those tenants to each region. So of course we can do that using also a particular region for like landing page, and then forwarding the tenants or the users to the closer region to do the onboarding, the registration, sign up, etc., whatever they need to do in their own region, or just using different domain names for different regions and authentication, etc. So every application, depending on, of course, on our application and the requirement in terms of availability and reliability, we need to design in different way. But in all the cases, we need to take into account the key services for disaster recovery, because although these services are important in terms of high availability. So remember, you have to use at least more than one region, if not for active, but at least like hot standby, depending on how critical is your application. The storage. Using S3, we have high availability, same for EFS, Glacier for backup, EBS, as well for block storage, import, export, if we want to do physical backup to AWS or from AWS, storage gateway, the same way if we want to put our local backup in S3. We can use from the compute side EC2 instances using AMIs and autoscaling groups, because the autoscaling groups create more instances, of course using AMIs. With networking, so we have Route 53, which is a high available service, and the same for elastic load balancing. And databases, we can configure RDS, DynamoDB, and Redshift, also in multi-AC deployments, in cluster, etc. And in terms of orchestration, we can use CloudFormation to deploy our services in multiple locations, to deploy our infrastructure at the end of the day. Elastic Beanstalk also to have a service, a managed service for our applications. And OpsWorks for configuration management. So as a summary, we have learned about reliability, high availability implementation, and what services we have to take into account to create these different implementations, depending, of course, on the availability that we want to offer.